Welcome back to this video series on npm PowerUP. In this video we will look at how to implement fuel gauging in any existing Zephyr RTOS firmware application running on a compatible Arm Cortex M4 or M33 core. Before following the steps in this video, make sure you have followed all the steps in the second video of this series, as it builds upon the work done in that video. Ideally, you should now have a custom battery model that you had profiled yourself of your own battery, like we learned in the third video of this series. I do not have such a custom battery model, but the process of how you can add this to your Zephyr RTOS firmware application can also be shown by using one of the bundled models that comes with npm PowerUp that I will save in the source folder of my application. And once we have our battery model created, we can go back into VS Code and start working on our application. So for demonstrating how to add this to your application, I will be using the same peripheral LBS sample that we were using in the start of this webinar, and I will just print out the state of charge on a terminal window. And the first thing I have to do is I have to take the battery model I created, and I'll have to copy paste it into my source folder for the app, like this. The next thing I'll do is I'll go into my apps and I will open this npm 1300 fuel gauge sample. This is just a standard sample from the SDK, and in the source file I will take the fuelgauge.c and the fuelgauge.h, and I will actually copy paste this into my existing project, into the peripheral LBS that I'm editing now. So this goes into the source files here. You can see we have this battery model already here. I will rename it so it's easier to work with without the parentheses. Then we go into our CMake lists, and then we add this target sources app private source fuelgauge.c. Yeah, fuel_gauge.c. And in our main file, we will add some includes. We will include fuelgauge.age. And we will also define a sleep time, which is the frequency of how often we'll call the fuel gauging. Let's call it every second. And then we also want to add the charger. Then we can scroll down to our main loop. Let's see here. And what we want to do is initialize the charger. So I have this already written up. I will just copy paste it. Let's initialize here. And then we also need to add our fuel gauge update. So let's just add fuel gauge update charger. The last thing we have to do is to add the kconfig for using the fuel gauge library. And then we can build. Okay, we got some errors. That's my mistake. One thing we have to do is that we have to change out the battery model that's used in the fuel gauge C file. Let's see here. Fuel gauge C is referring to a battery model, which is not what we want. We want the name of my file, which I will handily copy. Here. And we never ended up using the sleep time because there was already a sleep time in the let's try again. And we have successfully built the peripheral LBS with fuel gauging included. And then we can program this back into our dev kit setup. And if we now connect to the terminal of the dev kit, we can see that it is actually estimating state of charge on this battery to 99%. And it's decreasing because it's using current. And that's how you implement fuel gauging using the nPM 1300 PMIC on any Zephyr RTOS application. Thanks for watching this video series on npm PowerUP.